Okay, before we start our today's session, uh, is there any questions? Okay, seems no questions. We are good to start. So today's concept is yesterday we discussed the vSphere storage concepts and we configured the NFS data store configuration. And today's session, we are focusing on the iSCSI storage. Okay, and iSCSI storage configuration, VMFS data store creation in our home lab. So let's observe our today's agenda. Agenda is vSphere storage summary. Yesterday we discussed the storage summary, but quickly I will show you one more time, because if we have a visual idea on all our storage summary, it's easy to understand VMFS data store and its functionalities and iSCSI architecture. Okay, once we have a basic idea, it's easy to understand these two concepts. So quickly we can run through the our vSphere storage data stores. So yesterday we discussed these points. Data store, we know it's a logical unit. It consists of all our virtual machine files, templates, and ISO images. And vSphere storage supported four types of data stores. Within these four types of data store, the first one is VMFS, virtual machine file system, and the second one network file system, and virtual SAN in vSAN, and virtual volumes. In short form, we call it as vVols. So within these four types of data stores, we discussed about NFS storage and how to configure NFS storage yesterday. So today's session will focus on the VMFS. Okay, so and also observe the logical view. Yesterday, when we configuring the NFS storage, we configured over the network only. We configured a file server on Windows Server 2022. But today's session, we are focusing on the VMFS data store, and VMFS data store. We required a real sandbox, but instead of sandbox, same like yesterday's session, we configured NFS role on our Windows 2022 server. Similarly, we do not have a original sandbox, so but the similar lab we can perform on a Windows Server 2022. Within the Windows Server 2022, similar to NFS, there is another role which is called iSCSI target server. If we enable the iSCSI target server, our 2022 server will act like a iSCSI storage. Okay, so we'll configure the block using Windows 2022 iSCSI storage. Once we configure the iSCSI storage, when we presenting that storage to ESX level, the file system format is VMFS file system. And the protocol we are using today is iSCSI protocol. When you are configuring FC and FCOE, the protocol will change. Okay, so today we are focusing on iSCSI SAN and also the VMFS. And another logical view, even for our easy understanding, within our four storage types, the green one NFS we completed, and within the VMFS, even the direct attached storage, we know how to add the direct attached storage. And we are going to observe iSCSI SAN, okay, how to create the LUN and all, we are going to observe today. And also the another quick view on our conceptual diagram. Even in the conceptual diagram, we can just to focus on the middle one, iSCSI array. Within the iSCSI array, we have a main interface cards are two interface cards, iSCSI HBA, hardware iSCSI HBA, and software iSCSI HBA. Today, I will show you how to configure software iSCSI adapter, because we do not have a physical iSCSI HBA card in our lab environment. So in our home lab, if we do not have a iSCSI hardware HBA card, we have a facility to do software iSCSI. So I will show you the software iSCSI, how to configure, and this software iSCSI adapter, again, it's connected through our physical network interface card. It will connect to the our iSCSI sandbox, iSCSI array. But which this iSCSI array, instead of physical box, physical storage box, we are going to configure on a Windows 2022 server. Okay, so hope you have some idea on our vSphere storage overview. Now let's start with the VMFS data store overview now. So we already know VMFS is one of the data store. So we'll also talk about some additional points on VMFS. If you observe the right side diagram, we have two ESXi hosts and all the virtual machines stored on a data store. And this data store name is VMFS. This is the usual icon for data stores icon. I use the same icon for data store. And this is a VMFS version 6. In our ESX environment, present latest to VMFS version. It's starting from VMFS 1, 2, 3, and 4, 5, and so on. But the latest available VMFS versions are two versions, VMFS version 5 and version 6. 6 is the latest version. Okay, and let's talk about the some additional points. VMFS is a clustered file system where multiple ESXi hosts can read and write to the same storage device simultaneously. Simultaneously means it's a concurrently we can create the virtual machine, you can read and write the data, and also you can delete the VM. Anything we can perform simultaneously on a data store, VMFS data store. This clustered file system provides unique virtualization based services. The specialty of this VMFS is it will support for all our vSphere features. I given the three examples. The three features are vMotion, HEA, DRS. So vMotion means migrating of running virtual machine from one ESXi host to another ESX without downtime. So today during the once we create the iSCSI data store, I will show you this one, but the in detail concept we'll discuss in the subsequent classes. And HEA means automatic restarting of virtual machine on a separate ESX host when a host failure. Suppose in this diagram, all of the sudden my ESX host is down. When the ESX host is down, nothing impact to the production. All this virtual machine automatically migrate and restarted on another ESX because our storage is shared storage. Using this shared storage, nothing impact to the data. It's immediately migrate and powered up on another ESX, even though when the host is failed. That feature call it as high availability feature. And another feature is DRS. DRS full form is storage scheduler, distributed resource scheduler. Sorry, using DRS, it will balance the load across the ESX host. Suppose I have two ESX hosts in this diagram. Certain time my ESX host is reaching over 80% CPU or over 80% memory. That time we no need to do any manual migration. If you enable the DRS, it will automatically balance the load. Wherever the ESX host is loaded, it will move one virtual machine to another host to balance the load among the ESXi hosts. Okay, that is the purpose of DRS. In later classes, I will explain in detail for all these three concepts, but just understand what is the benefit of using VMFS data store. It will support for these three key features. And currently ESXi supports for both VMFS 5 and VMFS 6, both versions it supports, but the recommendation is always will go for a latest VMFS version. So can anyone tell me what is the available versions in NFS?
and 4.1.
Yeah, NFS versions are 3 and 4.1. Very good. Okay. And now VMFS can be deployed on three kinds of SCSI based storage devices. So this SCSI based devices means our hard disk, whatever the hard disk we are using in the storage box, all the hard disks are which is the SCSI based storages only. SCSI means small computer system interface. This SCSI also we have advanced SCSI disks like SAS. SAS also uh, solid is SAS also one of the advanced to the SCSI, and we also have SSD disk. We can also have flash drive, but all are based on this SCSI based storage devices. But these devices we can deploy on a three types of storage. One is direct attached storage, in short form DAS. This DAS is like a local hard disk only. And the fiber channel storage. Fiber channel storage, we have two supported protocols. You can use either FC protocol or FCOE protocol. FCOE means fiber channel over Ethernet. And come to the iSCSI storage, our protocol name is iSCSI protocol. Okay, so within these three storages, whatever the storage you use, when you format in a ESX level, it will format with a VMFS file system. Now we are going to observe the differences between VMFS 5 and VMFS 6. It will cover our VMFS data store features and functionalities. So when comparing the VMFS 5 and 6, I just highlighted what is the main differences I highlighted in the different color. Suppose let's talk about one by one. The features and functionalities. When we see the first point, access for ESXi host version 6.5 and later. 6.5 and later means 6.5, 6.7, 7.0 and 7.0 update 1, 2 and 3. All the ESXi host version you can format with either VMFS 5 or VMFS 6. Both are supported. Suppose accessing for ESX host version 6.0 and earlier version means before 6.0, we have a 5 series versions, 5, 5.1 and 5.5. But most of the companies already migrated to 6. But in your environment at any certain situations, if you have a 5 series version, that scenario, we recommend to configure only VMFS 5 because VMFS 6, it won't support usually, but in our KB article, some articles refers as no, but some article refers as yes. But most of the scenario, VMFS 5 only recommend to choose when we are using a old version of ESX. But the latest version, when you start from 6.5, you can go for a VMFS 5 and VMFS 6. Here, I just mentioned as is a star, or we can make it as no, because the when we are using a lower version, only the supported version is VMFS 5. And data store per host. Normally, when we are using a one ESXi host, either ESX7 or any 6 series host, per host, how many data store support is? Both versions, it supported maximum 512 data stores we can create. And there is a storage devices, different type of storage devices. The different type of storage devices, normally it's saying as a 512n. A 512n means native storage device, and 512e emulate storage devices. And there is a some other devices like 4K native storage devices. This is the hard disk storage device types. Currently I highlighted the bold color. These three are the available storage devices. When we compare with the VMFS 6, the latest version 512E storage device is compatible only in the VMFS 6, but in the VMFS 5, it's supported only in a if you are using in a storage box level, but not supported for a local device level if you format with a VMFS 5. But the difference between these storage devices, logical sector size is 512, physical sector size is 512. But when you compare with the latest version 512E, the physical sector size is increased. It's a 4096. But when come to the very latest version 4KN storage device, this is the model 4KN storage device. It's a logical sector size, physical sector size, both are same. It's a high performed storage device. But this storage device is supported only for VMFS version 6. It's not supporting for VMFS version 5. So some of the interviews they may ask, I have a two version of VMFS. Why should I choose VMFS version 6? Can you elaborate some any key difference? So that time you can highlight this point. 4K native, N means native. 4K native storage device support is only for VMFS 6 and it's not available in a VMFS 5. And also there is another key difference in VMFS version 5 and 6 is automatic space reclamation. Reclamation means suppose in my data store, VMFS data store, there is some old data. I deleted the old data. When I delete the old data, by right data store has to show we cleared the some disk space, it has to show the some free space. But certain situations, VMFS will not show, even though if you delete some data, it won't show the cleaned up space. That is nothing but a reclamation. But when comes to the VMFS 6, whenever you did this honey housekeeping on data store level, whatever the size you housekeep, the entire space will be we can reclaim when we are using a VMFS version 6. This point also important. You can utilize when and anyone asked in the interview or when you're writing the VMware certificate professional exam, you may expect this kind of difference question. Okay. And another point, manual space reclamation through ESXCLI command. We know about ESXCLI. It's a one of the command. It starts with ESXCLI. When you use ESXCLI command prompt, in that command prompt, you can have an option to do reclamation. But automatic reclamation method is only in the VMFS version 6. and the space reclamation from guest OS. Guest OS means virtual machine guest OS. So in our guest OS, if you want to reclaim the any of the housekeeping space, that space in VMFS 5 is limited, but in the version 6, it's a possible. And GPT storage device partitioning. Generally, GPT means GUID partition table. GUID means it's a global unique identification partition table. Same like our network interface card, it has a unique MAC address or unique physical address. Similarly, whenever we configured one storage device, that storage device also have a unique partition IDs. That partition IDs we call it as a GPT storage device partitioning. GPT means GUID partition table, and also GUID means it's generally a global unique ID partition table. Okay, that partition table also it's always you have a unique identification number, and nowhere you can find the same ID. Okay, and this GPT partitioning is supported for both device. Okay, and we can also verify the comparison of VMFS 5 and VMFS 6 for VMware vSphere features level. So if you see the comparing of VMFS 5 and VMFS 6 for all the VMware features, suppose if I start from top, even the MBR storage device partitioning. MBR means master boot record. It's a normally when you install a Windows operating system, by default, the first partition is stored in a MBR partition only. Okay, even VMFS also it's supported for MBR storage device partitioning. And the storage device greater than 2 TB. Suppose your storage size is greater than 2 TB for each VMFS extent. Each VMFS extent means each VMFS data store is more than 2 TB. If you want to configure also, our both versions are compatible. And the support for virtual machine. Suppose even one single virtual machine, you are trying to add the virtual disk size is greater than 2 TB also it's supported. So normally in the real-time environment, most of the database servers will configure with a more than 2 TB sizes, and web server and application servers sizes are usually less than 1 TB. For database servers only, we require a more than 2 TB sizes. And the support of small files of 1 KB file also we can store in a VMFS 5 and VMFS 6. And the default use of ATS only locking mechanism on storage devices. Even for our storage devices, virtual machine disk, if you want to set any locking mechanism in our VMFS level, it's a by default locking mechanism is enabled. That is ATS only locking mechanism. ATS full form is automatic test and set. So it's a default locking mechanism. Even if you want to encrypt your hard disk, virtual hard disk, we can encrypt. It's the same like if you observe normally the office laptop or home PCs, when we log into the system, we configured as a BitLocker for encryption password, or when logging in, we are setting one password. Using that password only, we can log into our system, we can access our data. Until unless if you do not have a password or locking mechanism, we cannot access our data until we know the specific password. Same way in our virtual disk also, by default, it's supported for all the locking mechanism. Okay, that locking mechanism name is ATS only, automatic test and set only mechanism. Okay, and block size by default, our VMFS 5 and VMFS 6 block size is 1 MB. 1 MB means whatever the file you copied in a VMFS data store, let's say my file size is 0.5 MB. Even if you copy a 0.5 MB file, but VMFS 5 and VMFS 6 default block size is 1 MB only. Suppose if you copy a 0.5 MB file also, it's consume 1 MB space. For example, if I copy a 2.5 MB file, even if you copy a 2.5 MB file, our default block size is 1 MB. That means if you copy 2.5 MB file, but in our VMFS data store, it consume 3 MB file size. Okay, that is a usual file format. Just for easy understanding, even if you format your thumb drive 16 GB thumb drive or 32 GB thumb drive, it won't show exactly the 32 GB value because it depends on the thumb drive block size. It will shows the less than 32 GB partition size. When you format, it won't show the equivalent 32 GB size. It will show less than 32 only. That means it depends on the block size only. It will represent the available size. And come to the additional VMFS supported features. Even we just now discussed the vMotion. Even we also have vSphere, some additional features: storage vMotion, high availability, DRS, RDM. RDM means raw device mapping. All these features also you can easily configure on both VMFS 5 and VMFS 6. Okay. So within this version, both VMFS 5 and 6 main comparisons are the highlighted in the first slide. So it have the main comparisons, and the key point is automatic space reclamation functionality available only in VMFS version 6. It's not available in a VMFS version 5. Okay. So now we can start discussing the iSCSI storage architecture. So this is the iSCSI storage architecture. We can start discussing the what is the main key components in iSCSI storage architecture level. Excuse me. Let's start from the bottom to top. Let's say if you observe in the bottom of the diagram, there are two ESXi hosts. I just mentioned host. It's not only limited to two hosts. Even if your environment have more than two ESXi hosts, all the hosts also the architecture is same. And within the two ESXi hosts, in order to access our storage network means whatever the network we are using, that is called storage network. But iSCSI full form is Internet SCSI. Internet SCSI means it's always based on the IP network only. IP network means we need a normal network switches. If you have normal network switches, using the switch only we can connect it to the sandbox. Generally sandbox looks like this, and the hosts are we have a 2 ESXi host. If you observe the first host, it have a HBA, two HBA cards. HBA means host to bus adapter, and we need a normally a host bus adapter card to connect to our IP network. Once we connect to the IP network, from the IP network we can access the sandbox. And also this host have a multi paths. When you have multi path means in case of any one path is down, still we can access our storage. So always recommend to choose multi path communication only for both dash NFS storage and as well as iSCSI storage and also the FC-SAN storage. Always recommend to configure as a multi-pathing. So here, if you observe here, first host is configured with multi-pathing and second host configured with a single path. And here the host is connected using software iSCSI. It's connected to the switch. From the switch, it started accessing the storage box. So the point here I mentioned is servers with iSCSI initiators, hardware or software. So you can use either hardware HBA card or software HBA card. So, and this one is we call it as a iSCSI initiator. Okay, this is the initiator. And comes to the second one. Second one is a TCP IP network. TCP IP network, the recommended components are only switches only. For our easy understanding, I given you two switches. But if your ESXi host count is more than 10 ESX hosts, depends on your ESXi host ports, we can increase our switch count also. Okay, so depends on the host port count, we can increase the switches also. Similar to the servers network also we need to increase. And now let's talk about the storage concept. Normally when we are accessing from iSCSI initiator ESXi host to storage, that our storage we can also call it as iSCSI target. Our main target to access the data storage, our target is iSCSI target. iSCSI storage area network box, iSCSI storage box. So within the iSCSI storage box, in our iSCSI storage boxes, we have a multiple vendors in the real-time scenario. We have a HPE Nimble storage, that is also one of the iSCSI SAN, and the NetApp also one of the vendor name. And NetApp also providing the storage boxes. It will also provide iSCSI storage box, NAS storage box, FC SAN. Based on our requirement, we can procure the storage box. And EMC Clarion, EMC also one of the vendor name. They also produce the storage boxes, official storage boxes. So normally in the real-time scenario, depends on our customer budget, we can choose the any vendor's storage box, iSCSI storage box. But all the storage boxes, vendor names are different, but the storage box concept is same. Every storage box have a two storage processors. Here if you see SP means storage processors. It has two storage processor. For our easy understanding, we can say SP1, SP2 or storage processor A, storage processor B. When we have a two storage processor, in case of any one network connection is down, still we can access from a another storage processor connection. This is also have a, it supports for a multi-path connectivity. Excuse me. And then you can see in the within our storage box we have a disk array. Disk array means it's a series of disks. This disk we can also call it as JBOD. JBOD means just a bunch of disks. This all the bunch of disks, we can procure the bunch of disk depends on our requirement. You can at a time procure the disk arrays, multiple disk arrays, or any kind of disk arrays we can purchase. Suppose here in this diagram we have a one disk array. Using this disk array, even in the left side I mentioned that this is nothing but a physical hard disk, and the disk array and the entire box we consider as a iSCSI storage system. Within the iSCSI storage system we have a physical hard disk. This hard disk you can use SCSI hard disk, SATA hard disk, SAS hard disk, flash hard disk. Any latest model hard disk is the recommended to choose. Okay, so we have a physical hard disk. Using this hard disk, we can group the few hard disks and create one LUN. So grouping of multiple hard disk is nothing but a LUN. It's a similar like in our networking, we are creating a port to group. Port to group means grouping of multiple ports. We are making a one port group, VMKernel port group and VM network port group. Similarly, when you want to present a LUN to the ESXi host, we need to create a LUN. Depends on our existing disks. You can group the multiple disks, make it as a LUN. That LUN you can present it to the ESXi host. So LUN full form is logical unit number. We have a multiple logical unit numbers here. It's not only three, we can create n number of LUNs depends on your available physical hard disks. Okay, so this is about the our storage concept. Even if you see the tomorrow I will explain the FCSAN. FCSAN also same like the same disk array, and we have the LUNs. Only difference in the FCSAN is instead of IP network it will have a fiber channel switches. Apart from that, entire concept for FCSAN and iSCSI SAN both are same. In our iSCSI SAN, we are using a normal network switches, but when comes to the FCSAN, storage box concept is same, but only instead of fiber channel, instead of network switches, we are using a fiber channel switches. Example, brocket switches. Okay, so this is about the iSCSI storage architecture. Our main key components in storage level, ESX level, and our IP network level. Okay, all these components whatever we have, all these components I'm trying to explain one by one again in the descriptive format. Okay, so this is a description for all the all the components. Let's understand one by one. The first one is an iSCSI SAN consists of iSCSI storage system which contain one or more LUNs. Even if you see in the diagram we have a three LUNs are available, and the LUN numbers also always unique LUN number only. For example, LUN 1, LUN 2, LUN 3. If you want to create another LUN, it will be a sequential number or randomly it will pick the LUN number. So the same point here, which contains one or more LUNs and one or more storage processors. Storage processors also we have a, not the one, we have a more storage processors. And the communication between the host means our ESXi host, and the storage array occurs over the TCP IP network. TCP IP network means it's a IP network through our physical switches. And second point, ESXi host is configured with iSCSI initiator. This initiator can be hardware based, or in some cases we can use a hardware or software based. iSCSI host bus adapter. The adapter name we call it as a iSCSI host bus adapter. And sometimes the initiator can also be software based. This is known as the iSCSI software initiator. You can configure anything, but in our today's lab, we are going to configure as a iSCSI software initiator. Okay, because we do not have a original sandbox in our lab environment. That's why we are preferring to choose software initiator. But in our real-time scenario, most of the time we prefer to choose iSCSI HBA, hardware HBA only for better performance. And the third point, an initiator transmits SCSI commands over the IP network. A target receives SCSI commands from the IP network, and we can have a multiple initiators and targets in our iSCSI network. iSCSI is SAN oriented because iSCSI initiator finds one or more targets, and you can configure multiple initiators and also you can configure a multiple targets. It's not belongs to only one storage. Even if you want to connect to another storage box, we can configure a multiple targets also. So the initiator finds one or more targets. It's not only limited to one storage box, even you can access multiple storage boxes targets. And a target presents LUNs to the initiator. Always the target, the iSCSI target purpose is it will present the LUNs to the our initiator. And the initiator sends SCSI commands to a target. Even the initiator also sends the SCSI commands to target. Okay, and an initiator resides in the ESXi host and target resides in the storage array. This is important point. In our ESXi host level, we consider as a initiator, and in our storage level, we consider as a target. The same point I highlighted here. Storage level we consider as target, and in our ESXi host level, we call it as iSCSI initiator, and that are supported by the ESXi host. And iSCSI arrays can use various mechanisms, including IP address, subnet mask, authentication requirement to restrict the access to the targets from host. So it's also a very important point. If you want to access the ESXi host from the ESXi host, if you want to connect your storage box, iSCSI target can be accessed through either IP address or any of the authentication mechanism. The same point they mentioned here, including IP address, subnet mask, or any authentication requirement. Normally in the iSCSI authentication mechanism is CHAP, CHAP. That is one of the iSCSI authentication mechanism. CHAP full form is Challenge Handshake Authentication Protocol. Using the CHAP protocol only, we can assign the credentials. Okay, so in our lab we do not have a original sandbox, so I will show you where we can find the CHAP authentication. So that is the used for during iSCSI target configurations. Okay, now we are familiar for the iSCSI architecture components. Now we are going to understand the iSCSI addressing, how we can define the iSCSI addressing. So this diagram will try to understand the iSCSI addressing. Other than the standard IP address, normally iSCSI server also have a iSCSI storage or iSCSI target have a one IP address. So other than the standard IP address, iSCSI targets are identified by names as well. Not only the IP address, it's also identified by the name, but the iSCSI target name represent in a three types of addressing. Either you can use IQN addressing, or you can use UUI addressing, or you can use any alias name also you can use, or IP address. Any method we can connect our iSCSI target. iSCSI target is nothing but a iSCSI storage box. And initiator, iSCSI initiator means our ESXi host level. Even our ESXi host level also, there is a three types of addressing. You can use IQN addressing, or you can use alias addressing, or IP address. Within the IQN, you can use IQN format or UUI format, any format we can use. IQN means it's a iSCSI qualified name. I mentioned in the below. The iSCSI qualified name format takes the form of IQN. You can see the IQN and year. Year means here the example year is showing as 1998, and here the example for year is 1992. It's a generally understand that IQN addressing always the format is like this: IQN dot year hyphen month dot domain. Domain is nothing but here it's a .com is the domain, and my company is the subdomain. Suppose in our lab demolab.com. .com is the primary domain and the demo lab is the my company, and IQN is the actual LUN number. Which LUN number you want to choose, the same LUN ID number, and also the LUN ID have a unique identification number. This is the information. So here also below I mentioned same naming hyphen authority unique name. So this is the actually unique name. And even if you see the initiator also same naming convention: IQN, year, month, domain, subdomain, and also the specific data store name. So data store name is always unique name. Example I given as a store 10. And the IP address for our ESXi host, I mentioned three IPs. Let's say in our home lab environment, we have a three ESXi host, 71, 72, 73. For this three ESXi host, we are going to configure the iSCSI storage, but iSCSI storage we are going to configure on our Windows Active Directory system. That system IP address is 70. Either you can use IP addressing for easy communication, or you can use IQN format. Any format we can use to communicate. Okay, so the same points I trying to provide you in a descriptive manner. So this is the description for all the addressing. So let's try to understand the all the description. The main addressable discoverable entity is a iSCSI node, and iSCSI node can be an initiator or a target. Anything. If you consider from initiator level, it's an initiator. If you consider from the storage level, it's a iSCSI target. Anything, an iSCSI node requires a name so that the storage can be managed regardless of address. iSCSI name can use one of the following format. It can be a IQN format or EUA format. IQN full form is iSCSI qualified name, or EUI full form is extended unique identifier. And IQN can be up to the 255 characters long. So it's a 255 characters long. That's why it's a very lengthy address, but it's a separated by dot and colon. And the same point mentioned here, the prefix is IQN, and a date code specifying a year, month in which the organization registered the domain or subdomain name used as the naming authority string. So naming authority string is, this is the naming authority string. And next one, the organization naming authority string, which consists of a valid reserved domain or subdomain. And optional is, it's separated with colon followed by a string assigned to the organization choosing, which must make each assigned iSCSI name unique. So always this IQN address is unique only. Okay. Now try to understand the another format of iSCSI addressing. Another format is UOI addressing. The prefix starts with UOI. If you observe, the target address starts with UOI, and the initiator address also starts with a EUI. Okay, UI full form is extended unique identifier, and this is also 60 followed by 16 character name, and the name includes 24 bits of company name that assigned by the IEEE, and 40 bits for a unique ID such as a serial number. So either you can use IQN format, UI format, or else you can go with a either simple alias name and IP address. Normally the most easy method is either you can choose IP address or alias name. Any name we can use, easy to access our iSCSI storage box or iSCSI target server. Okay, so hope we understand the addressing, how we can configure the addressing, and we'll also talk about the iSCSI initiators. iSCSI initiator, just now we discussed the main initiators are hardware iSCSI, software iSCSI. We'll little elaborate about what is hardware iSCSI and software iSCSI. See, this is the diagram. So iSCSI storage architecture, within the architecture, one of the key components are iSCSI initiators. So in our iSCSI initiators also, let's understand the first diagram. It's a software iSCSI, and the second one dependent hardware iSCSI, and the third one is independent hardware iSCSI. Within the hardware, again we have two types: dependent hardware iSCSI, independent hardware iSCSI. If you observe this diagram, you can easily understand what is a software iSCSI mean. Within our software iSCSI, we require a network card. Let's say the network card company is Broadcom 570, one of the model for network card. Within this network card, if you want to configure a software iSCSI on our ESXi host, the requirement is we need to configure VMKernel port group. Within the VMKernel port group, we need to assign a iSCSI initiator and TCP IP. That means iSCSI initiator assign one IP address and also configure with the network driver. It will act as a software iSCSI. Okay, and comes to the dependent hardware iSCSI. Here, what is the main requirement? Here also we require a network interface card, normal Broadcom network interface card, but the model is different. Model different means usually all the models of network cards it won't support for a dependent hardware iSCSI configuration. Only few models only supported. If you want to choose the specific model, remember that when we are doing the server installation, we verified the VMware compatibility guide. Same way, when you are purchasing the specific dependent hardware iSCSI, you can verify in our VMware compatibility guide and validate that this hardware is supported to configure hardware iSCSI. If it is supported, then only you can choose this specific NIC card. Okay, or else you can go with a software iSCSI. Or else some scenarios you can purchase the hardware iSCSI, independent hardware iSCSI. But why there are three differences means obviously the cost is high for iSCSI HBA card. If you want to reduce the cost, you can go for a dependent hardware iSCSI NIC card. Even the budget, if you want to reduce the budget, go for a software iSCSI. But obviously, when you use a low cost network card with the software iSCSI, the performance will be not up to the mark. If you need a better performance, we'll go for a hardware iSCSI only. And here in the dependent hardware iSCSI, still we are using a specific model of NIC card, and that NIC card is supported for iSCSI initiator and the TCP offloading engine. And here also we need to configure VMKernel network adapter with network driver. Excuse me. And come to the independent hardware iSCSI. Here we are using a physical iSCSI HBA only. We are using a independent hardware iSCSI. Here I mentioned one example model. Model is QLogic 4062C. This is the model number. This is also by default it's supported for iSCSI initiator and TCP/IP offload engine. This hardware card, you can directly enable the VM kernel IP address. It will detect with a iSCSI HBA driver. Normally, these drivers and all we no need to install. It will comes with when you connect the NIC card or HBA card to our motherboard, it will automatically get the latest drivers. Just in case if there is no driver, our specific vendor and whenever we purchase from QLogic and all, they will provide you the installation details. During the installation, we need to update with the latest driver. Okay. The same point I just highlighted a point. We must set up a software or hardware iSCSI adapters before an ESX host can work with iSCSI storage. To access iSCSI target means our actual storage box. Our ESXi host uses iSCSI initiator. That initiator can be either software initiator or hardware initiator. Okay, so the same description I also given in the following slide. Here I given the all the description: iSCSI initiator, software iSCSI initiator, hardware iSCSI initiator, and what is the differences. Okay, and finally I mentioned the one key point: the final decision on the storage adapter to purchase can be driven by many factors. The main key factor is cost, failover capabilities, CPU overhead, and whether booting from SAN is required. Suppose if you want to configure booting from SAN, during that scenario, software iSCSI is not recommended. Even the dependent hardware SCSI also not recommended. We should recommend to go with a independent hardware iSCSI. That means we need to buy a separate HBA card in order to support the booting from SAN. So always remember, based on our requirements only, we can choose the specific cards. Okay. So all these points I covered here. Later it will be useful for you to refer the all points. Okay. And now we can observe the iSCSI storage configuration and how we can create a VMFS data store. So this is a high level plan. So how are we going to configure? Here, the first step, same like our previous yesterday, we discussed the VMFS. Similarly, we are going to configure the yesterday we configured NFS. Similarly, we are going to configure VMFS today. Okay. So let me show you this information on spreadsheet also. It's easy to track for us. Let's open the spreadsheet. Okay. In this Excel sheet, I just highlighted all the points. Okay. So when we finish the one topic, we can just quickly put the update. The same way we can do the lab also. Okay. So the first one, set up the iSCSI storage environment. But in the real-time scenario, set up the iSCSI storage environment means normally we need to configure our original storage box configuration setup. Usually this storage configuration is taken care by storage team. A storage team will do the all the configurations. But we must aware that there is a iSCSI storage configuration is going on. And in our home lab, we are choosing the iSCSI storage server as 192.168. And our AD server, which is 70. Okay, I'm choosing this server as a lab purpose. Okay, and next, install and configure any iSCSI adapters that our storage requires. Obviously, we need to choose the iSCSI adapter, either hardware iSCSI or software iSCSI. Now we're going to configure the software iSCSI adapter. But before configure software iSCSI, we'll configure this one. We need to choose which one to configure. I just mentioned that we are going to configure as a software iSCSI. But in the real time scenario, we need to choose depends on the customer requirement. Okay. And now create a VMKernel port group. This is also one of the pre-configuration requirement. So we can create a VMKernel port group, dedicated VMKernel port group for iSCSI storage configuration. So, and also we need to get the iSCSI storage addressing or IP address. You can get the addressing information from storage team, or you can get the LUN details, all the information you can get it from the storage team. But here we will get it from our lab only. Okay. So usually we need to get from a storage team. Okay. And now CHAP authentication. Using if you want to configure the authentication, CHAP authentication. CHAP full form is Challenge Handshake Authentication Protocol. This can be configured for iSCSI storage area level. Okay, SAN level only we can configure. Okay, this is also optional. I just this information also we can get it from our storage team. And vmkernel port group is our as a VMware engineer, we need to take care this port group creation. Okay, and verify that storage devices we are planning to use for our data stores are available. So which data stores, how many data stores are required, all the information also you should be ready with that. Okay, and now the point is add iSCSI target server role on Windows Server 2022. Okay, we'll log into our lab, we'll do the all these steps one by one. So let's log into our lab system, go to the our Active Directory server. So here we know this system IP address is .70. Last octant is 70. Suppose you can just quickly log in. Okay, I'm type the IP config. Our server IP address is 70. Okay, so this server is our domain controller also. To verify the domain controller, command is type net space accounts. See, it's our primary domain controller. So within our primary domain controller, open the server manager. So when we open the server manager, even in the first page itself, we can find the what is the roles are configured. We configured Active Directory, DNS we configured, and also we configured NFS storage and local server. We did some configurations and all the existing server events and services information. So now as per our iSCSI storage requirement, we need to add the iSCSI target server role. So if you want to add that role, just log into our Active Directory system or any member server. Even in the member server also you can configure this role. Instead of creating another Windows VM, I'm just trying to use the same system. And let's verify the space also. Suppose in our C drive we have 200 GB, but within the C drive yesterday we created a NFS data store. But to avoid the confusion, we'll add a new disk. That new disk we'll use for a iSCSI. Okay. To add the new disk, what is the procedure? Right click the virtual machine, go to the edit settings, and let me add the new hard disk. So select hard disk, click on next, SCSI hard disk, next, create new virtual disk, next, and we can store it as a single file. And the size you can give some random size. Let's say I'm giving the size as a 250 GB, or let's give as a 300 GB. Okay, 300 GB I'm going to create. Click on next. So disk is going to create this disk. If you want to create on the default location, it will create on the default virtual machine folder. If you want to change the location also, you can just click on browse and you can change the location as well. Let's say uh, okay, our C drive is here. Okay, it's fine. Let's create on the same location. Click on finish. Disk is created. Now click on OK. But whenever we added a second hard disk, go to the edit settings. See, second hard disk 300 GB is added, and it is using a SCSI based protocol only. SCSI, small computer system interface. So this disk will not come here automatically. In order to add the newly added hard disk, the procedure is log into the guest operating system and go to the start run and type the command disk mgmt.msc. You can type in the Explorer tab or you can type on a run command. Either way you can type. Let's say I'm just typing here disk mgmt.msc. Disk mgmt means management, disk management. MSc means Microsoft Console. Click on OK. So when we log into the disk management console, you can see here 300 GB is in a unallocated space. And also here it's in the unknown and offline state. Let's try to bring it to the online. So before bring it to the online, right click here, bring online. And also it's still in the red color. Just right click, try to initialize the disk. So we are trying to initialize the disk. Today we discuss the two partitions. MBR means master boot record, GPT means UID partition table. These two partitions are supported for our VMFS partitions. We discussed in our today's topic during the VMFS differences. See, MBR also supported and also the GPT also supported. GPT point here. GPT storage device partitioning is supported. Even Windows also default it support for two partitions, MBR level or GPT. Here GUID means a global unique identification number. Okay, now when we select the GPT, click on OK. So basic, it's in the online state. It's a disk is in the unallocated level. You can just right click the disk, create a simple volume. Click on next, choose the complete size. Default it's pick the sequence of letter. Already D drive is assigned for CD, so it's pick the sequential letter D E. Now click on next, perform quick format. Default Windows file system is NTFS. Click on next, finish. So we created a new disk also. This disk we are going to use for our iSCSI storage configuration. Okay, so disk also ready. In our, if you open our spreadsheet, this kernel port group we can create. We are going to add now as a iSCSI target server role. Okay. Log into the server manager, select the add role features. When you select the add role features, the condition is we should log in with administrator account. Already we log in with administrator account and network IP settings and the latest patch. We already meet all these conditions. So click on next. And the role based feature, we are planning to do role based feature only. So click on next and choose our default host name. Our host name is ad01.demolab.com and our system IP address. Click on next. And here we already installed Active Directory. We installed DNS. And if you want to see the iSCSI, here there is no iSCSI name, that is find only under the file and storage services. Just expand here. You will find the file and iSCSI services. Again, expand here. You can see file server is installed and the server for NFS also installed, and look for a iSCSI target server. See, there is a iSCSI target server. Even this iSCSI target word remember that word we mentioned in our today's slide. During the components, our storage is considered as a iSCSI target. The same iSCSI target, instead of physical box, we are trying to configure on a Windows operating system level. So enable iSCSI target server. Click on next. When we select the iSCSI target, and the features are currently there is no additional features for iSCSI. You can just go with a default features, no need to enable anything. Just click on next, and it is going to configure the iSCSI target server. Normally no need to restart. Generally this iSCSI role not required any restart. Just click on install. So installation is in progress. Okay, see, installation succeeded on Active Directory server. So now click on close. So if I want to verify this role information, even in the same server manager, here you can find the iSCSI. Because the iSCSI is configured under file and storage services only. You can just double click here, it will open a console. So here you can see server, volume, disk, storage pool, shares. Shares is for yesterday we configured for NFS, but for iSCSI we need to select iSCSI only. So when you select the iSCSI, in the right side you can see that there is no iSCSI virtual disks. So there is no virtual disk. Here it's a software layer, it is showing as virtual disk, but in the physical hardware storage box level, we need to configure a LUN. But now instead of configuring the LUN, we are creating here, creating a iSCSI virtual disk. So just click on here to create an iSCSI virtual disk. Start the new iSCSI virtual disk wizard. Just click here. When you click here, you can find the option for new iSCSI virtual disk wizard. Select our server name and you can choose the which drive you want to configure. Let's say you can choose either C drive or E drive, but today we added a separate drive for iSCSI configuration. So you can choose the second drive. Either you can create a drive, select the drive, or you can create a custom path. Any method we can use. So now I'm just selecting the E drive. Click on next. When we select the next, it is asking for specify the iSCSI virtual disk name. So any name we can provide here. So I am creating the name as iSCSI hyphen LUN1. We are creating a first LUN. So I'm creating as a iSCSI LUN1. And the description also, if you want to write any description also, we can mention the description here. Usually in the real time scenario, the descriptions and all we need to put the when we are creating the date we need to mention here. Just for a standard practice, we can put when we are creating the date we can present here. Let's say today's date, and now click on next. This is just a description only. Click on next. Now free space, we have the within the disks we have 300 GB. Using this size, either you can assign complete size or you can assign a limited size also. Suppose I'm assigning as a 200 GB or I'm planning to assign as a 250 GB. And we have a multiple options here. Fixed size means this 250 will be fixed. In future, if you want to extend, we cannot extend, but dynamically expand option is the recommended. So difference also no need. We'll go with a default option. And we can assign the sizes in the MB, GB and terabyte level. So let's leave it as a GB now. Now click on next. See, this is the iSCSI target. So you can, it is asking for assign the iSCSI virtual disk to an existing iSCSI target or create a new target for it. But present we do not have any iSCSI target. Let's choose the option for new iSCSI target. Now click on next. And here the target name and access we need to provide here. You can use the same name or I'm just assigning as a iSCSI SAN. iSCSI SAN. Let's say this is the first sandbox, so I'll keep it as a iSCSI SAN 01. This is our actual iSCSI target. This is also call it as a alias name. Okay, now click on next. See, it's saying that the specified target name contains one or more characters are not valid. So maybe it is not accepting the hyphen and all. It's a space actually. Let put the hyphen SAN and -01. Description can be anything. Now click on next. See, when we keep the space, it's not a link. So I just mention as hyphen. Now click on next. See, in the next option is specify the access servers. So what are all the servers we need to provide the access. But in our lab environment, we have a 3 ESX host, ESX1, ESX2 and ESX3. When you select the ESX1, 71 IP address, ESX2 is 72 and ESX3 IP address is 73. So we'll assign the same 3 IP addresses here. These are all the iSCSI initiators only. You can see iSCSI initiator. So now click on add. You can choose the options here. Let's say enter the value for the selected I type. You can enter either IQN number. If you have a hardware iSCSI, you can use IQN number, or else just select the drop down menu. You can find multiple options: DNS name, IP address and MAC address. For easy method, I'm just selecting the IP address. So enter our ESX host IP address: 192.168.10.71. When you select this one, click on OK, it will add the IP address. And similarly, if you want to add another host also, select here, enter the value selected type, choose the IP address and add our IP address: 192.168.10.72. Click on OK. So here I have a two IP address are I added. So two ESX hosts are already added as a iSCSI initiator. OK. Now click on next. So when we click on next, it is showing us enable authentication. So today in our topic, we discussed that in order to access our iSCSI storage, there is a default authentication mechanism. That authentication protocol is CHAP protocol. CHAP means challenge handshake authentication protocol. When you enable CHAP, we need to provide a dedicated username and passwords. And when you want to access the storage, we always use this ID. But in our test lab, no need to specify the specific IDs. Let's leave it blank. But in the real production scenario, depends on our storage team requirement. Sometimes they may configure CHAP, sometimes they may leave it as CHAP blank. They will use the default administrator accounts. Okay, it's up to our convenience. And now the finally confirmation wizard. You can see iSCSI virtual disk location. It's in the E drive, and virtual disk properties. We assign the size as 250 GB, and our target server is this is iSCSI target server. That means it's our SAN server alias name. And IP address is we assigned this to access the server. We are providing the initiator IPs here, and the security access we just disable. Now click on create. When you click on create, see if you observe here, what is the steps it's did it? Create a virtual disk completed. So that means one LUN is created, and set the iSCSI virtual disk description also we set it, and create iSCSI target completed, and set the target description also completed. Set the target access. We also provided the access to our two ESXi host, and assign the virtual disk type to see even virtual disk is assigned to the target. Okay, now click on close. When I click on close, you can see in the below, this is our AD server name and our virtual disk's path. When you scroll down below, you can see the iSCSI targets. Suppose if you want to add any of the additional node in future, how we can add is just select the specific target, right click. There is options: disable target, remove target, and properties. Currently, we no need to disable or remove. Just go to the properties. When you go to the iSCSI target properties, here still if you want to do any modifications, we can perform modifications here. We want to add a initiator. So what is our initiator we added? We added two initiators, 71 and 72. If you want to add a additional initiator, the procedure is click on add, and you can choose our third ESXi host IP address. Select the IP address and enter the IP address: 192.168.10.73. So I'm just selecting our third ESXi host also. Click on OK. So this is how, even if you want to add in future any multiple options, just come to the iSCSI target, go to the properties, and you can add how many hosts we want to add. All the list we can add it here. Okay. So only for this three hosts only, our this LUN is accessible, and other host it won't accessible because we given permission only for three hosts. So just apply. And if you want to in future, if you want to update your authentication, you can update your security authentication. Okay, CHAP authentications. And the connections, currently we are not using a iSCSI initiator connection in IQN address. We are just using a IP address. Any method you can use. Okay, this option also I mentioned in our today's slide. See, while assigning the addressing, you can choose either IP address or you can choose IQN format. Any format you can choose. But generally, even if we didn't choose the IQN format also, by default, it will pick one IQN addressing format. We can observe the IQ and addressing format in our ESX host level. Okay, now just click on OK. So this is the configuration at the our Windows 2022 server level. Hope you understand the configuration. I quickly show you one more time. Even if you want to configure, go to the tools and here, or else just go to the home server manager. Just go to the home. This is the option, add role feature. Click on next. Next, here only we can choose the our iSCSI target. Under file and storage services, expand, you can choose iSCSI target server. See, if you see here, already installed state. Just select next, next and finish. And once the configuration is completed, again come to the iSCSI console and you can create a target here. Okay, suppose if you want to create another new target, new iSCSI virtual disk and you can create. Okay, so we already created a target here. Yeah, you can observe the address here. You can see here in the target IQN, it's showing us some default year, month, .com is the domain name, subdomain name, and also the our iSCSI addressing. Okay, like this we can observe the addressing, IQN addressing. Okay, so now it's the time to back to our vCenter server and add the VMFS data store. Before adding that, we'll just try to update our checklist. So let's open our checklist. Verify that storage device we are planning to use for our data stores are available. We already added a one disk for dedicatedly for the storage device configuration. So I just make it as a done. And the add iSCSI target server role on our Windows Server 2022. This portion also we completed. And the other option, create a folder or disk and provide iSCSI storage permissions. It's a optional. We haven't given the CHAP authentication permission, but we have a permissions for server permissions, administrator account permissions we have. So just make this as a done. And what is the next option? Update the dynamic discovery target details. So these options we are going to perform from our vCenter level. So it's clearly saying that update the dynamic discovery target. This option we need to perform. And also remember, we need to create a dedicated VMKernel port group. And also we need to configure a software iSCSI. So to configure software iSCSI, we'll perform now. Log into the vCenter and we'll configure a software iSCSI first. After the software iSCSI configuration, we'll do the VMKernel port group. But before creating VMKernel port group, and we need to choose the additional IP addresses. Go to our demo lab spreadsheet. Yesterday we used 3 IPs for NFS and we'll choose the 84, 85, 86. This 3 IP we can use for a VM kernel IP address. Okay, 84 we can use for ESX1, 85 for ESX2, and 86 for ESX. Like this, we can utilize the multiple IPs in the real-time scenario also. We always update the our inventory whenever we start using the new IPs. We need to update our inventory. Okay, let's back to our lab system and let me log into the vCenter server. Open the browser and our vCenter server IP is 79. Okay, launch the vSphere client HTML5. It is showing a site cannot be reached. Let me see the status. Our host is in the healthy state only. network, everything is okay. Let me try to connect from SSH session. Oh, okay. We have already put it. Okay, I just connected to our vCenter server via command line. This is in the default command. If you want to type the shell commands, just type shell here. So we connected to vCenter server. Let me clear the screen. And to verify all the service status, service hyphen control hyphen hyphen all space hyphen hyphen status. This is the command. It will help you to show you the all the services are up and running or not. See, all the services are running state and a few services are stopped. These are seems to be not required services. Okay, our main vSphere client service, vSphere UI user interface service is running. Okay, you can verify from command line. This is the command service hyphen control hyphen hyphen all hyphen hyphen status. This is one method, or else another method is you can verify from the WAMI page also 5480. Here also you can observe a root. So health status is showing as okay, and the services status also showing as let's startup type all automatic is running state, started state. So no service issue. Let me try again why it is not connecting. Enter. Launch HTML5. So let's try to start the services again. Start. You can type the command start or restart. Anything we can type. Let's say start. Okay, it's started again. Okay, refresh. If it is still not working, we can give one restart and try. Let me clear the history and try. Okay, better we'll reboot once. Same from the command line, command is reboot. Excuse me. When we log into the workstation, we can see the reboot status. Okay, vCenter is rebooting. Reboot may take 2 to 3 minutes time. Okay, it's up, and we'll verify the service status again. Right click, restart session, root and password. Okay, it's login and type the shell. So we are in the shell prompt now. So the command service space -control -all -status. See, still few services are need to start up. Only few services started and few in the pending state. We'll wait for a while to connect the vCenter. Few still in the stop state. Slowly it is starting the all. We require this service first. vSphere UI. Okay, VA is going to start now. This is a way we can verify the services status through command line, or else we can connect to WAMI page and verify the service status. Any method is okay. It's taking some more time. Let's try again. And sometime browser cache also, it will stop accessing the vCenter. Just clear the browser cache every time. Okay, it seems Whisper UI is still in the pending state. Slowly it's starting all services one by one. Okay, it started now. vSphere client. Okay, we'll try now. So it's saying that web server is initializing. Okay, we need to wait some more time. Refresh. Okay, it seems almost all services started, and image builder, this and all we are not using, and VCHA also not using. It's fine. Main service are started. Okay, we'll try again. It seems everything is okay. Somehow it's not working. Let me try accessing from already. Okay, here it is working. Okay, let me try again outside. Okay, here gateway is 10. Sorry, some IP mistake. Okay, let's try now. Okay, our network adapter having misconfiguration here. Okay, now it's connected. Gateway also okay. We'll try now. Hopefully it will work this time. Okay, just with the interest of our time, we'll try to log in from AD server. Our vCenter login is administrator at the rate vSphere.local. Okay, our vCenter server is up. Here ESX123, it is showing some power state warning. but connection is okay. Just reset to green. Excuse me. So, as per our checklist, what is our first step we need to do? We have to create a VM kernel port group and also configure a software iSCSI. Okay, we'll try to configure software iSCSI first. In order to configure the software iSCSI, select our ESXi host and the right side go to the configuration tab. Under configuration tab, you can see storage section. Okay, we have storage, network, virtual machine system, multiple options. Under the storage section, you can choose the option for storage adapters. So when you see the right side storage adapter section, there is an option to add software adapter. This is the option. When I click here, you can see the drop down menu option, add software iSCSI or FCOE adapter. So anything you can configure. So just click on add software adapter and there is options. Add iSCSI adapter or add NVMe non-volatile memory over TCP adapter or FCOE adapter. This FCOE for normally to access the FCOE sandbox, but in our scenario we are choosing the add SCSI iSCSI adapter. So select here. This is a software adapter only. Add software iSCSI adapter. Just we are just adding a new adapter. Click on OK. When we click on OK in the recent task, you can see adapter adding status. See in the first row, VMHBA 65. It took the default number. VMHBA means virtual machine host bus adapter 65. It's a software adapter and you can see addressing also default identification address. Okay, it's added. This is the IQN number, year, month. That address format is it's automatically selected. Okay. Similarly, second host also. The second host, storage adapter, add the software adapter. Click on OK. This adapter is needed to connect our iSCSI target. Again, select ESXi03, add software adapter, click on OK. Just refresh. Yeah, it's added. ESX3 software adapter added and 2 also it's added. 1 also it's added. Okay, so we can update our checklist. So this option is completed. Now VMKernel port group. VMKernel port group also we know how to create. Go to the VMKernel adapters. Yesterday we created a one management and one VMKernel for NFS. We have a 74 IP address. Same way, if you want to create another network, just click on add networking. And while add networking, we need to choose VMKernel network adapter. See, this VMKernel is helpful for iSCSI also. Not only NFS, it will helpful for iSCSI access also. Click on next. You can use an existing network or select an existing standard switch. So I'm selecting the existing standard switch. We switch 0, click on OK. Click on next and we can enter the name any of the label. So VM kernel for iSCSI. This is the name I'm giving and IP version 4. OK. And we have to assign the IP address now. IPv4 settings in the next tab and we need to choose the service. Even iSCSI storage also option is management only. There is no specific iSCSI name. We'll choose as a management. Click on next and enter the IP address. So IP address we are planning to choose as per our IP list. Start with 87, 88, 89. So let's choose the 87 IP here. 192.168.10.87 and subnet mask same 255.255.255.0 and the gateway you can use the same gateway and click on next. So VM kernel for iSCSI, okay, all settings are fine. Click on finish. So it's create a VM kernel 2 is created. This is for iSCSI access purpose. Same way we can create on ESX2 and 3. So I'm just adding on ESX2 now. We switch 0 next and VM kernel better choose the same name. IP address, select the management, click on next and assign the IP address. IP address is 88 and the subnet mask gateway, click on next, finish. So VM kernel 2 also created and ESX3 also same. This procedure is common for even the production iSCSI SAN. If you want to add, we need an additional VM kernel network. Next, assign the IP address. So this IP address and all, we can get it from our network team. Or if you have any available IP spreadsheet, you can get it from the spreadsheet also. Click on next, click on finish. So 3 VM kernel adapters are added. So this one also, let's make it as these 3 are in use for these 3 hosts, and VM kernel port group for iSCSI. Here typo, sorry. Okay, I just updated our inventory sheet, and in our iSCSI implementation plan also, it's already completed. Now come to the update dynamic discovery target details. So we need to update the dynamic discovery on our ESXi host level, log into the vCenter server, and we can plan to identify the target information. Just go to the storage adapter, select the software adapter, and here we can look for a options. When we select the software adapter, you can see properties, devices, paths. When we see the paths, currently there is no path, even the device also, it's not detected any device. And dynamic discovery. See, dynamic discovery, there is no information. We need to assign our target information here in order to discover the our existing new LUNs. So for dynamic discover, go to the dynamic discovery, click on add, and here we need to enter our iSCSI server details. So server details, you can enter fully qualified domain name or IP address. So let's enter our IP address. 192.168.10. Our iSCSI server configured on .70 system. So I entered the same IP and inherited authentication settings from parent. Okay, it will automatically get the credential also. Click on OK. So when I click on add the discovery option, see it's detected with IP, and remember that iSCSI default port number is 3260. This is the default port number. Okay. When we add this information in the here, it is showing the some warning message due to recent configuration changes. A rescan of VMHBS6 is recommended. Okay, we have to do the rescan. The rescan point also I mentioned here. To discover newly added storage device, perform rescan. Okay, so this point we completed on one host, we do it for another host also. So again, same way you can go for ESX2 and add the dynamic discovery information. Select the adapter. When we select the adapter, go to the dynamic discovery and add our iSCSI server details. iSCSI server port number is 3260. Click on OK. So it's added. See, you can get the warning message for rescan. Same way for ESX1 also, you can add our iSCSI server details under the dynamic discovery. Click on OK. So when we add this one, rescan we have to perform. See, the rescan option is available here. Rescan storage. You can do it from single host level or go to the data stores tab. Under data store tab also we have an option to do the data store scan. Here actions also you can find the scanning options, or else better we'll do it from a host level. Go to the storage devices, storage adapters, see the rescan storage. See, rescan storage option is showing as scan for new storage device or scan for new VMFS volumes. But we haven't added new volume yet, but we just added a new device. So let's try to rescan the for the new discovery for our iSCSI storage server. So click on OK. So similarly, we can do it for second host also. Rescan storage, click on OK. And select the third ESXi host, rescan storage. Okay, if you see the recent task, rescan for all the ESX1, ESX2, and ESX3 is completed. Okay, so we'll update our checklist. So rescan also completed. What is the next step? Log into the vSphere client, browse the host or cluster data center, and we need to start creating a new data store now. So let's log into the vCenter, select the host. If you want to create a new data store, go to the data store tab and choose the actions option. Okay. So present we have what is the data stores available is we have VMFS 6. It's a local data store, and we also have the option for NFS 3 data store also we created. Now we are going to create another VMFS data store using the our iSCSI server. So go to actions, choose storage, new data store. And here, which is the recommended type we need to choose for iSCSI storage? Is it NFS, VMFS or vVol? Which one we need to choose?
VMFS.
VMFS. Very good. So VMFS means it's for a create VMFS data store on either local disk or LUN. Our iSCSI storage providing the LUNs only, logical unit number. So recommend option VMFS. When we select VMFS, click on next. See here, it's automatically detect our 250 GB size. Okay. And the name, if you want to keep the any name, we can keep the name. Let's say for easy understanding, iSCSI data store short form. I'm just using DS hyphen. This is the first data store. I just mentioned as iSCSI DS01. So select our data store and click on next. See, it is showing the VMFS version. Today we discuss the VMFS version, VMFS 5 and 6. See, 5 is enables 2 plus TB LUN support and VMFS 6 enable advanced format. See, 512 E support also is there and automatic space reclamation also is there. So due to these additional benefits, we'll go with a VMFS 6. Click on next. And the partition configuration, see if you see here, the default block size is 1 MB. Today we discussed the block size also during the comparison table. And the space reclamation also 1 MB and the space reclamation priority low. You can use the default option. If you want to use the complete size, you can use complete size, or else if you want to give only 100 GB also you can choose. Either you can choose from this data store size or you can enter manually also here. Any option we can choose. Suppose for example, I want to give only 150 GB. You can just type here accurate value 150 GB I'm giving. Click on next. See now if you observe the all the summary information before we complete, data store name is iSCSI DS01 and the LUN information, LUN is assigned as a, this is the default LUN address it is showing, and VMFS version 6 150 GB partition format is GPT. Now click on finish. When you click on finish in the recent task, you can see data store addition is completed and even iSCSI data store is added. And remember whether it is iSCSI or FC, still it uses the file system format is VMFS file system only. So we choose the version VMFS 6. This is how even in the real-time scenario, when your storage team provide the iSCSI storage detail, the storage addition is same procedure. Just go to the action, new storage, and you can choose the new data store and you can add the any relevant data stores. NFS dedicated only for NAS storage and VMFS is dedicated for both local disk and also the LUN. LUN means fiber channel LUN, iSCSI LUN or FCOE LUN. Any LUN you can choose VMFS. And virtual volumes is a software defined storage and it will configure as a vVol. And vSAN also software defined storage. I will show you in the later sessions. Okay, so we are familiar with how to add the data store. And even the another host, we no need to add it manually because we already added as a dynamic discovery IP. So we'll check that ESX2 also it's added automatically or not. Select ESX2. See, there is automatically added. When you add for one ESX host, other ESX hosts are automatically discover the our existing LUN. And even ESX3 also it's automatically discovered. Suppose if I click on this data store, go to the host tab, see this data store is shared between three ESXi host. The same one I explained in the today first diagram. ESX host uses the data store, that VMFS data store always shared between the three ESX host. Okay, and now we'll go back to our spreadsheet. See, new data store we created and version also we choose, and it is option to available for all the hosts. It's assigned for all hosts. We finished until the configuration procedure. Now let's observe the post installation steps. Even the post installation steps, validate the new VMFS data store on iSCSI based storage device. Yes, we configured from the new VMFS only. We verified the VMFS version also. It's a 6 only. Our validation also completed. And the next point is make sure that new VMFS data store is available to all hosts. We verified for all 3 hosts is accessing the our same data store. When I click iSCSI, it's accessible for all 3 hosts. So this point also completed. And another point, create a virtual machine and verify the virtual machine files on VMFS data store. So this one also we are familiar. Yesterday we created one virtual machine on NFS data store. If you want to see the virtual machine file, select data store, right side, go to the files. We can see the NFS test VM. Okay. Same way we can create the iSCSI test VM also. Let's select the cluster, right click, either a cluster or ESX host, anything we can choose. ESX1 already running with one test VM, ESX2 also running with NFS test. Okay, we'll choose the ESX3. New virtual machine, create new virtual machine and choose the ES default data center, and virtual machine name will keep the one name. Let's say iSCSI test VM 01. Okay, click on next, and we are choosing the data ESX host 3. Click on next, and here the recommended data store is we plan to test the iSCSI data store. Okay, select the iSCSI data store, click on next. File okay, compatible with our ESX version, and choose any Windows OS, click on next. And customizing the hardware, if you want to customize, you can customize. Excuse me. And hard disk size I'm giving as 40 GB, and virtual machine network we can change it to VMX 3, and even the hard disk type recommend to choose as thin provision just to save our disk space. Click on next, and this is the ready to complete summary page. All the details are okay. Now click on finish. So virtual machine creation is in progress. See, in the recent task, create virtual machine completed. When the virtual machine creation is completed, just click on iSCSI test VM and go to the summary tab. You can see our data store location is iSCSI data store. And to verify the files, just click on data store, go to the file location, select the virtual machine folder. Inside the folder, you will have the virtual machine files. Okay. So hope you understand how to verify. Even the same file, if you want to test on iSCSI server level also, just minimize this and log into our iSCSI server. Within iSCSI server, our drive is E drive. Just open the E drive. iSCSI virtual disks are created. Inside the disk, just see the icon is disk only. When you open this disk, okay, it's showing as permission denied because it's not a NFS storage, file storage. It's a completely iSCSI. So we cannot see it from here. We can see only from the vCenter level. Okay, due to the iSCSI SAN, it's a secured box. So last point also completed. So that's it for today. Let's try to update our discussion items. See, yesterday we discussed the NFS storage and all. We completed until NFS. Today's session, we covered the iSCSI storage architecture, components, and we discussed about VMFS data store features and functionalities. So these 2 topics are completed today. And adding the iSCSI target role on Windows Server 22. We did this lab also. Okay, and we also created a VMFS data store configuration and management. We created and also we verified whether the virtual machines are able to successfully created on VMFS or not. That is the nothing but a management. Even suppose in future if you want to increase your data store, just select the data store, go to the actions tab. In our actions tab, there is an option, multiple options here. like increase data store capacity, unmount data store, even delete data store. Anything tasks we can perform. This is all the our data store management tasks. So within the management task, suppose if I want to increase the data store capacity, present in our summary tab, if you see data store capacity is 150 GB. So go to the actions, increase data store capacity. So select the remaining data store capacity, click on next. See, earlier it was 150, 100 GB is available. So it's automatically selected 100 GB. Click on next, click on finish. So when you click finish and see in the right side, data store space is increased. So these are all the data store management tasks. Whenever you want to increase, you can increase data store. Even you can place the data store into maintenance mode, same like ESXi host, unmount the data store, delete the data store. Generally, data store maintenance we can do when we plan to upgrade the VMFS version from 5 to 6. During that scenario, we have to do. Okay, but normally we won't do the any specific maintenance. Only during the version upgrade time only we can perform the data store maintenance. Okay, this all comes under the data store configuration and management tasks. Okay, so that's it for today. If you have any questions, please let me know. Okay, if no questions, we can end the session here. Thanks for your time. Keep practicing. Okay, bye for now.
Okay, sir. Thank you, sir.
Thank you.